In this chapter, we'll learn all about the basics of standard lights in 3ds Max, the different types of lights and how to apply them. First, we need to just get some basic concepts under the belt. When you open up 3ds Max, the perspective view will be defaulted to a realistic mode. You can see that here, realistic. And if your video card supports it, then you'll get shadows and maybe ambient occlusion, which is contact shadows. You can choose which features by clicking on the label here that says realistic or whatever the current shading mode is. And you can go under lighting and shadows and enable and disable things. You'll see here it says illuminate with scene lights, but there are no scene lights in the scene currently. I haven't created any. That means that we will get default lighting. Okay, so first of all, you need to make sure that illuminate with scene lights is on in order to see any lighting in your scene. And again, in absence of scene lights, you'll get the default lighting. You'll know if you have default lighting if you orbit around your scene and the shadows sort of move around. That's a dead giveaway that the light is attached to the camera. Okay, so that's how you can always tell whether you're looking at scene lights or default lighting. Let's create some lights. Go into the Create panel and click on the Lights category. You'll see the default type of light is photometric. And that's a type of light that actually obeys physical laws. And you can plug in data from the manufacturer of certain lighting instruments and get physically accurate results. Usually you would do that in conjunction with the mental ray renderer. We're not going to be covering photometric lights in this course because it's too deep of a subject. However, there is an entire course just on mental ray lighting, and it's 3ds Max lighting and rendering with mental ray. And it goes into good detail about photometric lights and exposure control, etc. In this course, we'll be working with standard lights. Click on the pull-down list here and choose standard. Standard lights are so-called cartoon lighting. They're not based on any kind of real physical properties. And it's just merely an impressionistic sort of artistic process. Whereas photometric lighting has more of a scientific element because you're trying to simulate the way that light works in the real world. But the standard lights, again, are more cartoon or impressionistic tools. I'm going to create an omnidirectional light, sometimes known as a point light. It's going to shine in all directions equally. And in 3ds Max, it's called an Omni light. Click the Omni button, and then click anywhere in the perspective view to create that light. And once you've created it, you can right-click to exit creation. And right away, you will see something a bit strange. The light is positioned at a Z elevation of 0. And because of that, the ground plane does not receive any illumination. We get lighting on the figure and all these other objects, but the tabletop or ground plane here is not receiving any light. You have to move the light up in order to see that happen. Grab the Move tool and move that light upward. And as soon as you do, it starts to illuminate the scene. This is something that may take some getting used to. Let me maximize this view with Alt-W. What you will find with computer graphics lights is that as the light moves closer to the surface, paradoxically, the surface becomes darker until you get to the point where the light actually touches the surface and that surface goes completely black. And that, of course, is different to the way light works in the real world. Usually, as your light gets closer to something, it gets brighter. Well, if you do look extremely closely, you will notice that it gets a little bit brighter here in the center. Okay, why is this happening? It's happening because the way that the lighting model is calculated in 3D is very simple, and it's only based upon the angle of the surface to the light. If the surface is pointed at 90 degrees to the light, like this, then it will receive maximum illumination. Okay, so this surface here is at right angles to an imaginary ray coming out from the light. So that surface is pointing exactly at the light. It's facing the light. Surfaces out here are not at a 90-degree angle. It's going to be a much shallower angle. This might be a 45-degree angle up here to the surface. So that might be half as much light. If we bring the light down very close, then the angle to that same point in space may be only a few degrees. That may only be a 5-degree angle there. And so it's going to receive almost no light. And if the light is actually almost touching then that's like a 1 degree angle there to that point, and so there's going to be almost no illumination at that location. So it's really all about just the angle of the surface to the position of the light. And that's pretty much all there is to CG lighting. There are other bells and whistles we can turn on, such as shadows or decay, so that the light will fall off in intensity over distance. But all of those things cost. They require computation. And if you have a lot of features like shadows and decay and so on enabled, then that's going to cause the system to have to work harder to calculate all of that. So you will get reduced performance in the viewport, and your render times will be longer. So for the standard light, all that stuff is turned off by default. We will look at how to enable some of those features later in this chapter. In any lighting setup, whether it be real or virtual, you've always got a so-called key light. That is the dominant light source. It's the one that's the brightest and provides the most illumination, and usually also casts shadows. A good candidate for a key light is a spotlight. So you'll see in the lighting panel, we have target spot and free spot. Previously, we saw how target cameras and free cameras work. Well, for lights, it's exactly the same. I like to use the target spot because it gives me an aim point. Click on target spot. And in the perspective view, click and hold the mouse, and then drag out, and then release. Where you click, you'll create the light, and where you release, you'll create the target. And then grab the move tool, and you can move either one of those individually. All right, we can go out to the top view, Alt-W. That's always good for setting up our scene, because that's the plan view. Bring that light back. And the farther back that light goes from the scene, the more of the scene is going to be illuminated, because it's included within this cone. Bring that up. But you will notice that once we get a certain sort of critical distance away, the intensity is not really changed by the distance very much, because we do not have any kind of decay currently. Okay, I'm going to bring this over and try to illuminate the whole scene by moving that light up a bit more. But you'll see that we have some areas that don't get illuminated here, that are not quite in this cone area. All right, so we'll look at how to deal with that in a moment, but for now, we've got a light and a target, and we can select that target and move it as well. And all this is doing is actually rotating the light. Cool. Very simple. That, again, is a good candidate for a key light, or the dominant source of illumination. Let's look at the basic properties of the spotlight, which include its brightness or intensity and its color. By the way, I've made all of my objects nearly white here, and that's a good idea when you're setting up your lights, because if you have colored objects, then it's going to be more difficult for you to evaluate whether the lights are at a good intensity or not. What I've done in this case is I've selected all of the objects and then gone into their object color and set them to be nearly white. All right, let's select the light and go into the Modify panel, and you will see General Parameters. First of all, there's a switch to turn it on and off. There's also a switch to enable the target, so we can disable that. And if the target is disabled, then it's now a free light, and we would move it around and rotate it. You'd maybe go into gimbal mode to do that. So this is just another way of focusing the light. Turn the target back on again. And then we come to intensity, color, and attenuation. Open that up. And really, you've just got the multiplier and a color swatch. And the default of the multiplier is a value of 1. If we increase this up a bit, let's say we drag on this spinner, we will see the scene start to blast out. It's overexposed. There's too much light now. Okay, let's maximize this with Alt-W. A value of 1 is pretty good for a key light. You may need to actually bring it down from that. Once you add other lights into your scene, things might get blasted out or overexposed. As a general rule of thumb, the total value of all of the lights in your scene should never go over about a value of 2, assuming that you don't have any decay or any other kind of effects going on. All right, so that's the multiplier. We can bring that down, dim it out. We can actually set it to negative values, by the way, which will suck light out of the scene. Bring this back up to a value of 1. And then we have the color. And that's just like putting a filter over the light. Click on that, and we could create colored light really easily. Let's make it a pink light, or really any color we want. If we were trying to simulate daylight, for example, and this was light coming from the sun, we might make it just ever so slightly orange. And then we also use maybe some blue lights to represent the sky. Okay, cool. So simple enough. That's all there is to it. We've got an intensity multiplier, and we've also got color here. As you can see, the spotlight does not cover the entire scene. It's got a circular projection, and we can see that if we select it, then the cone is enabled there. The cone is actually a two-part cone. You can see there's two cones. There's actually an inner one and an outer one. And the inner one is the hotspot. Anything inside that inner cone radius is going to receive the full multiplier illumination. And then that is going to fade out to a value of 0 by the time we reach this outer cone, which is the fall-off radius. We can play around with those values. Let's go into Spotlight Parameters, and you'll see hotspot beam and fall-off field. I'm going to reduce the hotspot angle, so just bring that angle down. So instead of a 43-degree angle, I'm bringing it down to, let's say, a 10-degree angle. And now what you see is that the intensity diminishes more gradually, and we don't get such a hard edge there. So the difference between the hotspot angle and the fall-off angle determines the hardness of the edge. If I bring this back up to its maximum here, when I reach near the fall-off angle, what will happen is it will push the fall-off angle. And there's going to be a 2-degree difference between those by default. All right, so that's kind of a little bit unique. The hotspot angle will push that fall-off angle if you bring it out. So let's reduce that fall-off angle so we can really see that. Increase that hotspot, and that'll, again, push that fall-off. Okay, so there is a 2-degree difference between these by default. If you want a super sharp angle there, like a theater limelight, then you can actually accomplish that, but you have to go into Preferences to do that. Customize Preferences, and in the Rendering tab, you will find Hotspot Fall-Off Angle Separation. We don't actually want it to be 0 because that would create a really jagged edge, but we could set it to a very low value like 0.5 or something like that. Click OK. And then if I reduce that fall-off angle, you can see we're getting a sharper transition there. Cool. There's one other way you can do this actually, which is to use the manipulators. We haven't seen that yet in this course. Up here on your main toolbar, you have Select and Manipulate. And with that light selected, I can click on this, and you'll see the hotspot and fall-off cones light up in green. And I can just click on one of those and manipulate it directly. That's kind of helpful. All right, that's a Select and Manipulate tool. Turn it back off again. All right, there's your hotspot and fall-off angles. One of the most primary concerns in computer graphic rendering is gamma correction. Gamma is the contrast curve of an image. And gamma correction is applied at multiple stages in image acquisition, editing, and display. For example, a standard image that you would view on your computer has gamma correction embedded in the image. And its purpose is to track the human perception of brightness so that we can apply a sort of image-based compression mode. Basically, human eyes are really sensitive to dark areas, but they're not as sensitive to super bright things. And because of that, we can sort of exploit the characteristics of human perception and store more data in the dark parts of an image. And that's done by applying a gamma curve to the image. So gamma also comes into play when you're dealing with different types of lights. In 3ds Max, you have photometric lights and standard lights. Standard lights already sort of have gamma correction built into them, but photometric lights add together linearly, and contrast curves are applied at the end of that addition process. And that's done through an exposure node, or exposure control setting. So basically you need to have gamma turned on or off depending upon which type of lights you're using. In this example, in this scene, I'm using standard lights, but gamma correction is enabled by default. And what that's going to do is it's going to sort of wash out my rendering. And I would have to adjust all the colors of my lights and materials in order to get a more darker or saturated look. However, if I just disable gamma correction in 3ds Max, then I won't need to worry about fussing with all the lights and materials because I will be in the correct mode for the type of lights I'm using. So right now gamma is actually on, and it is on by default in 3ds Max. But since I'm using standard lights and not photometric lights, I want to disable gamma correction. Go into the Customize menu and go to Preferences, Gamma and LUT, which stands for Lookup Table. And you'll see gamma is on. I'm going to switch it off, and I'm also going to switch off the affecting of color selectors and the material editor. And when I click OK, watch what happens in my shaded realistic view here. Everything just got more contrasty, darker, and more saturated. And this is the effect with gamma disabled. That's going to make it a lot easier for me to achieve the look that I want using standard lights. Now that I've disabled gamma, I want to save my scene in this state. I'll go up to the Application menu and choose Save As, and I'll save it as 140502 gamma disabled.max. And click Save. Now when you store a file, the state of gamma is stored in that file. And when you load a file, you can choose either to load the gamma correction settings from the file or to keep the settings that 3ds Max has in its preferences. Let's take a look at that. If I go back up to the Application menu and choose Open, I'm going to reopen that same scene, the one that has gamma enabled. So I'm scrolling down and looking for 1405 gamma enabled.max. And then open that. And now I get a warning because I previously disabled gamma for 3ds Max in the preferences. So the system is set to have gamma turned off, but the file I'm trying to load has gamma turned on. We can see it here. System setting is disabled and the file setting is enabled. What should we do? Well, in this case, I actually want to keep the system setting. It's important that you understand how this works, because if I choose Adopt, it doesn't just adopt the file's gamma settings for the current scene and session. It will actually turn gamma on or off depending upon the state of the scene, and that will then be adopted by the preferences in 3ds Max from now on. So I've disabled gamma, but if I now choose to adopt the file's gamma, then I'm saying I want to enable gamma from now on forever. Just be cautious about whether you keep the system gamma or adopt the file gamma. If I choose keep the system's gamma, that's not going to mess up my preferences. I'll click OK, and now it looks like gamma is off, even though my file name says it's on. It's actually turned gamma off, and we can verify that by going back into Customize Preferences, and we'll see that gamma is indeed off. And I'm going to leave it off for the remainder of this lesson and this course. Although the 3ds Max viewports are getting better every year and giving us a more accurate preview of our rendering every year, there's still some features that we'll never be able to see in the viewport. And in those cases, you'll want to do a full rendering. You can go up to the main toolbar and click on the Render Production button, and you can get a rendering. However, that takes time. You have to wait for that to render, and also you have to make the effort of going up here and clicking this. And if you do a lot of changes, then it's going to be a kind of an interruption of your workflow to keep clicking that button. So there's an option you can employ here which kind of combines the interactivity of the viewport and the accuracy of the final production render. This is called Active Shade. And new in Max 2015, Active Shade works with both the 3ds Max default scanline renderer that I'm using now, and it also now works with the Mental Ray advanced production renderer. All right, so let's look at Active Shade. It will only work in a viewport that's not maximized. If you maximize the view and make it full screen, then you cannot load active shade into that panel. All right, so I'm going to go to the perspective button here, click on that, and choose extended viewports, active shade. And it may take a moment to think about it to render. This is a very simple scene, so it took a split second. But if you've got a complex scene with a lot of lights and heavy materials, then active shade may take a really long time to render. Once active shade has initialized, then you can make changes to your lighting and materials, and it will update automatically, and you don't have to keep clicking the render button. For example, I can move my light. Grab the Select and Move tool, click the light, and then move it to the other side, and active shade updates automatically. I don't have to click render or do anything. Or I can put it back. I could also make adjustments to the light parameters. I could go into the Modify panel and, for example, bring the multiplier down to 0.5 or something and dim it down. Set it back to 1. However, there are certain things I can't do. I can't move the camera, for one thing. And also, if I move objects in the scene, active shade will not recognize that. For example, if I select one of these objects and try to move it, it moves in these interactive views, but active shade doesn't reflect that movement. If I need to update that, what I do is right-click and choose Initialize, and it will re-render. Okay, and now we can see where that is. So I can put it back, and again, right-click and Initialize. Once you're finished using active shade, if you need to close it, right-click and choose Close. And now you're back at the ordinary viewport renderer, which is called Nitrous. That's the official name for the renderer. All right, so that was just a little taste of active shade, and we will also use that in order to explore some of the advanced lighting features in the next movie. One of my favorite features of 3ds Max lights is the ability to adjust the contrast of the light itself. We need to do a full rendering to see that, or use active shade. I'm going to load active shade into the perspective view, click Perspective, Extended Viewports, Active Shade, and then select the light. We want to scroll down. We're looking for a section labeled Advanced Effects, and open that up. And you will see Effect Surfaces, Contrast. And if we increase that, it does just what you would expect. It cranks up the contrast. And if we bring it all the way up to 100, then certain areas are going to be overexposed. You will see how in some of these areas, it's actually kind of posterizing a bit. Let's get in closer on the character because this will show up better on curved surfaces. I'm going to close active shade and then dolly in on my character. And then once again, extended viewports, active shade. With a very high contrast, we get an extremely hard edge, and we also get highlights that are kind of blasted out. I don't usually bring that up that high. If I use it at all, I might bring it up to about 50. So here's the value of 0, where we have a very fine sort of transition or gradient across that surface from the brightest part to the darkest. And then with a contrast of 50, it's a sharper transition. And with a contrast of 100, it's become posterized. Okay, I'm going to set the contrast down to 50. And then play around with this value here, Soften Diffuse Edge. And that's going to maintain this contrast, but it's going to make this edge be a little softer. Set the Soften Diffuse Edge to a value of 50 as well. And so it's not quite as harsh. I've increased the contrast, but then I've softened up that edge. Let's do a couple renderings so we can see them at the same time. I'm going to right-click and close, and then do a rendering with these settings of 50 and 50. And then I'm going to clone this window off so I can compare it. And now I've got a copy of that window. And then set these values back down to their defaults of 0 and 0. And render with the default settings and see the difference. Okay, so on the left we have default settings of 0 and 0. And on the right, we've increased the contrast and the soften diffuse edge to a value of 50 and 50. And essentially, it's brightened up the entire scene. The blacks are still black, but the brights have kind of spread out further and sort of taken over more of the image. Cool, so that's just one way that you can fine-tune the look of lights in 3ds Max. Shadows are critically important to the believability of an image. Without shadows, it looks like all of these objects and figure are floating above the ground plane. They don't look like they're actually contacting. We need to enable shadows, and let's look at the different types of shadows we can employ. I'll select the light, and then go to the Modify panel, and up at the top in General Parameters, we've got shadows, and they're off by default for standard lights. I'll turn shadows on, and if they're enabled in the viewport, then we will see shadows appear. Here there's a pull-down list where you can choose what type of shadow you want to use. And the default is Shadow Map. A shadow map is based upon a bitmap, or a pixel-based image that's projected from the light onto the scene. Ray trace shadows are vector-based, and they're based upon lines that extend outward from the light. So it's kind of like the difference between vector art and a bitmap. If you create an Illustrator document, for example, and it's made out of all paths and curves, you can zoom in infinitely on that, and it's never going to break up into pixels. Whereas if you have, let's say, a JPEG image, that's a bitmap made up of pixels, and if you zoom in enough, you're going to see the mosaic of pixels, and you can't break the image up into anything smaller than 1 pixel. The shadow maps are pixel-based, and ray tracing is vector-based. So you can expect that ray tracing is going to look better. In fact, that is the case. And you can also expect that ray tracing will be slower, and that is the case. Ray trace shadows are going to be slower, they're going to take up more memory, and they're basically going to be better but more expensive. Alright, so let's try the ray trace shadows. If I enable that, what you see is we get hard edges on these shadows. And we can't even really see it very well in the viewport because the viewport can only display shadow maps. But if I get in real close on one of these shadows here, and then do a production render, then we can see we have very sharp shadows here. So that's the ray trace shadows. You'll see there's also advanced ray traced. That just gives you some controls that you can play with to optimize the speed of the rendering. Whereas the standard ray trace shadows just don't really have any controls. Okay, you can see here under ray traced, all there is just the bias, which is the distance from the shadow to the receiving surface. And then advanced ray traced has a bunch more stuff in here to control the quality. So that's all about ray trace shadows. In the next couple of movies, we'll look at shadow maps and also area shadows. Shadow maps are pixel-based, and they have advantages and disadvantages. One advantage is they're fast. They render quickly. One disadvantage is that they don't respect opacity. So if you have a transparent object, it will cast a perfectly black shadow. So if you want really realistic shadows, you want to use area shadows. If you want quick and dirty, fast renderings, and just a little bit of blur on there is good enough, then use shadow maps. Let's look at the parameters for shadow maps so we can use them to their best advantage. I'm going to select that light. Once I've got the light loaded here in the Modify panel, I'm just going to pin the stack. Click that button, and that way we won't lose these parameters even if we deselect. So we can always get back to these. Let's try shadow maps. Turn on shadow map. And in the perspective view, you can see that it looks kind of grainy. But if you do a proper rendering, you will see something different. So let's select that perspective view and click on Render Production. And you see here in the actual rendering, it looks kind of blocky and not grainy at all. Let's lock this view so that from now on, we will only render this viewport. So click the little lock icon there. So that's a shadow map with default parameters. And you can actually see the individual pixels. The reason those pixels are showing up so large is because the shadow map is spread across the entire area of the light's fall-off cone. If I select that light once again, the image of the shadow is being spread across this entire angle here. If we increase the quality, or if we make that fall-off radius tighter, we will improve the shadows. All right, so by way of illustration, I'll reopen my rendered frame window. and clone this off to a separate window so we can compare them. Now I've got a copy here. This is with the light unadjusted. Then I'll select that light and go over to the Modify panel and play with the spotlight parameters. I'll bring the fall off in, so it's at 70 degrees now. I'll bring it into something like 30 degrees or even 20 degrees. All right, so we still see a shadow here. We're still in that zone. And I've got my render view minimized here. And I'll render again. And the only difference between these two renderings is the size of that fall off cone. So this one had an angle of about 20 degrees, and this one had an angle of about 70 degrees. And you can see there's a major quality difference there. Anything that you do that will change the size of that fall off angle is going to affect the shadows. For example, let's say I grab the Move tool and I switch over to local mode and I just move the light backward. That's going to spread the shadow over a larger area, and once again, that's going to degrade the quality of the shadows. And do another rendering, render production. Here it is with the light moved away, and it looks even worse now. So the distance actually matters. All right, I'm going to undo that, bring it back where it was, set the fall off back to 70. And now let's look at the actual parameters. So that we can see the effect a little bit better in the viewport here, I'm going to change the viewport configuration. Click on the plus sign and go to Configure Viewports. And in the Visual Style and Appearance tab, you have Lighting and Shadows Quality. I'm going to bring that all the way down to the minimum of point lights and hard shadows. Click OK. And now we're seeing a very blocky approximation. And that's good. That's giving me an idea of what the shadow map is going to look like. Back in the Modify panel, I'm going to scroll down and open up Shadow Map Parameters. And there are 3 parameters here. Bias is the distance of the shadow from the shadow casting surface. Size is the resolution, and sample range is the blur. Let's try playing with the size now. So I'll do another test render. Here it is with default parameters. Once again, I'm going to clone that off to its own separate window. And then increase the size. Let's set the size to 1024. It's a good idea to use powers of 2 because that's going to optimize memory usage. So always double that, 512, 1024, 2048, and so on. Let's render that. So on the left, we have a size of 1024, and on the right, a size of 512. And you can especially see it here. This is much softer. Okay? Let's try also playing with the blur, which is the sample range. I'll bring the size way down. Let's set it to a crazy value like 128. And then reduce the sample range down to its minimum, which is 0.01. And click Render. And now these are individual pixels blown up to huge size. All right, well, we'd never really use that value, but I'm just trying to illustrate. So to optimize this, to get a good look, I might do something like this. Set the size to 1024, but set the sample range up from where it was. It was set to a value of 4. Let's try that with a value of 4. But I could crank it up a bit more and soften this up. So let's try a value of 8. And now we're getting soft shadows everywhere. You may notice, however, that the shadows are not actually contacting the shadow casting object. And that's when we would want to play with the bias here. We can move the shadow towards or away from the shadow casting object. Lower values will move it in tighter or closer. We could set this to a low value like 0.1 and then render. And that's moved it in closer. And now they're actually in the right place. All right, cool. So that's one look we could achieve. Maybe we could make them a little crisper. Let's try a size of 4096. That's about the maximum you'd really ever want to take it up to. Anything beyond that, and the memory usage is going to be so much that you may as well just use area shadows or ray trace shadows. All right, with a size of 4K, I'll set the sample range back down to the default of 4 and see what that looks like. And that's not so bad. It's looking a little bit ragged there, so maybe I'll give it a sample range of 6. From a distance, that will look fine. So we can dolly back out again and render that. Pretty cool. So that's basically how shadow maps work, and that's how you can optimize their performance. For standard lights, the most accurate type of shadow is an area shadow, and that's more optically correct, and it respects things like distance. Let's take a look at the shadow maps once again. I'm going to actually select my light and move it over. Grab the move tool, make sure it's in world coordinates. I'm just going to move it over so I'm getting more side lighting. That's going to help us to see the difference here between these types of shadows. Okay, so with something like that, I'll select the perspective view and render. We've got that perspective view locked. This is the shadow maps, the settings from the last shot that we just did. And let's copy that so we can compare it. I've got a copy here. Just going to minimize that. So what you see here is that the softness of the shadow is uniform across the entire shadow. However, in the real world, the farther away the shadow casting surface is from the shadow receiving surface, the softer the shadow will be at that location. In other words, where the two surfaces are very close together, the shadow will be very crisp. But where the surfaces are far apart, the shadow is going to be softer and fuzzier. Shadow maps and the default ray traced and advanced ray trace shadows in 3ds Max do not respect that distance. And the reason is that the shadow casting mechanism is a point. It doesn't actually have any size. So it's an infinitely small point that's projecting the shadow. And that's why we have a uniform crispness throughout. An area shadow actually has a size, and because of that, then it's capable of this more optically correct or accurate rendering. All right, so let's select our light. Go back to the Modify panel, maybe pin the stack so we don't lose that. And instead of Shadow Map, I'm going to choose Area Shadows. And let's do a rendering with default area shadow parameters, see what it looks like. So you see that we're getting massive spread and a huge amount of grain. And this is simply because the size of the light is huge. My entire scene here is only 1 meter wide. Let's look at the area shadows parameters here. Open that up, and you'll see here the area light is 25 centimeters wide and 25 centimeters tall. It needs to be a lot smaller. Up here we have some options for what shape the area shadow light is going to be. Let's just choose disk because that's going to be the simplest. And then reduce the dimensions here to, let's say, 5 centimeters by 5 centimeters. So that's going to produce a circle that's a 5 centimeter radius. And we'll do another rendering. And now you can see this is looking a lot more believable. Let's look at our shadow map rendering to compare. On the right is the shadow map, and on the left is the area shadow. And you can see that's so much more believable there. There's some grain there, but we can fix that really easily. Just go back into these parameters here. Increase the integrity and the quality. Integrity is the accuracy in terms of the detection of the edges of surfaces. I'll set the integrity up to a value of 5 and render that. And it's made it better, but it's still looking a little bit grainy. And that's where the shadow quality comes in. Quality is actually the sampling. It's how many calculations are being done. I'm going to turn that up to a value of 10. With integrity of 5 and quality of 10, do another rendering. And each time I increase those, you see it gets slower, but it looks better. That's looking pretty clean now. Again, on the right, we've got a shadow map. And on the left now, we've got an area shadow with optimal parameters. If we change the position of the light or the position of the shadow casting object relative to the shadow receiving surface, that will change the softness here. Additionally, once again, if we change the size of the light, that's going to control the softness as well. If I want this to be sharper overall, I can reduce the size. I can give it a size of like 1 centimeter by 1 centimeter and render that. If you have a pretty crisp shadow here, you don't need to have as high of values for integrity and quality. So to optimize the speed of the rendering, you can bring these values down a bit. I can take them back down to their defaults of 2 and 5 and try that. And it rendered much faster, but it's a little bit crunchy there, so maybe somewhere in the middle. Maybe 3 and 8. Still looking a bit crunchy. So you just have to fine tune this until you find the right settings. So that's a 5 and 10. Let's try 4 and 10. I think I'm happy with that. So it's all up to you in terms of the look you're trying to achieve. If you want a really soft effect, then increase the size of these area light dimensions. Maybe set that up to a value of 10 centimeters, which is going to be super soft. That means this is going to need to be increased as well. So that's an extremely soft light. One important point I'd like to make about the area shadows. It's only the shadows that have a size. The light itself is still a point light source. And so we don't get an even diffuse illumination like we would if we used a proper area light with photometrics. So these are all point light sources, but the shadows are being calculated as if the light were an area light. All right, so that's a pretty exhaustive exploration of the options for shadows in standard lights. With only one light in our shot, we've got a very contrasty image. It's almost like a film noir movie in which the shadows are incredibly black, like the value of 0. Let's add a little bit of fill light to this so we can fill in some of those dark shadows. You'll probably want to use Omni lights for fill because those are the least expensive. They are the fastest to render. I'm going to unpin my stack, go back to the Create panel, go back to Lights, and Standard, and create some Omni lights. And I want to create those in the top view or the perspective view. Click to create the Omni light. I'm going to create 2 of them out here, and then right-click. And they need to be moved up because they have an elevation of 0. Bring those up. And not to the same elevation, give them some variation. And then obviously, as you can see, we need to adjust their intensity. The key light or spotlight here has an intensity of 1. Up at the top, we've got intensity color attenuation. The multiplier is 1. The fill lights I've just created, their purpose is to fill in the shadows, not to provide direct key illumination. That means that their multiplier or intensity value needs to be lowered. The key light should always be the strongest light in the scene. Select one of these. And intensity color attenuation, maybe set that to a value of 0.3 or so. And likewise with this one, bring that down a bit, 0.3. All right, so you can see the difference already here. We're getting some fill. The shadows are not 100% black. One thing I do want to point out is that 3ds Max remembers the settings for the last operation that you did on a light or on many other objects. So take a look at this. The Omni lights that I created have this cream color because I created a spotlight and adjusted its color, and now these new lights have inherited that color. So don't let that bite you. I actually want to set these to be the complement, which is blue, and that's going to give us a nice pleasing effect. So I'm going to click on that and just switch that hue over to a blue color with not very much saturation, just very desaturated, a saturation in the 20s. And you can see how that's affecting this. And let's select the other light. Likewise, change its hue to a blue. Click OK. And now this has got a little bit more visual interest to it because the key light is sort of slightly orange and the fill lights are slightly blue. And now we can kind of move these around and kind of control the contrast level. So if I bring these over to the side, that's more side lighting. Bring them up towards the front, that's more fill lighting. So again, it's just an artistic process of you trying to determine, what looks good. You can also create fake bounce light because light hitting the surface of the floor here should bounce up and strike the other objects here. So we can create a fake bounce light for that purpose. All right, let's create a new Omni light. Just standard Omni and create it basically at the target or near the target and then move it down underneath the floor. And because we're not casting shadows with this light, it's going to shine up onto the figure. You can see it there. So maybe not quite at the target, a little bit in front. We want to illuminate the figure more than anything. And we can bring it down maybe a little bit. Again, just play with that, see what looks good. It doesn't need so much intensity, and it should have the same color as the key light. Go back into its parameters. Set that color back to that cream color. And it should have a really low intensity, maybe like 0.1 or something like that, because it's just providing a little bit of splash or fill, maybe 0.15. Okay, so that's a little bit of fake bounce light there. All right, pretty cool. And then finally, we could put some rim light to kind of accentuate the edges of the figure. You know, some backlight. So we could make some omni lights and put them back here. And actually, if we want to, we can duplicate the existing lights. We've already set the color and intensity for these, so I can select one of them and just hold down the Shift key and drag it back here, and that'll make a clone. When I release the mouse, I get a dialog asking me, do I want to copy an instance or a reference? A copy will be completely independent, so I can control those parameters separately. An instance would have shared parameters, so if I change the multiplier of one instance, it would affect both of the instances. And a reference is an instance in which you can add modifiers. But you can't add modifiers to lights, so reference wouldn't make any sense here. In this case, I want a copy, so I have independent control. Click OK. And then this rim light now, I want to examine the figure here and move the backlight around so I can kind of put a little bit of a rim there. Right? If I put it back too far, we won't see anything, so kind of over on the side a bit. And that looks pretty good. I can make a duplicate of that. Once again, hold down Shift and drag and bring it over to the other side. And now I've created some rim light. So I'll make another copy here. And you can see here that we've kind of differentiated the figure from the background. And that's the purpose of the rim light. Nice. All right. So now that we've got all those lights in the shot, let's do a test render of that. You can see that it's a little bit maybe overexposed. Once I've added all of those lights in, I probably want to reduce their intensities. We can do that from the light lister. We'll do that in the next movie. The Light Explorer is a variant of the Scene Explorer that gives us control over all of the lights in the scene. And it supersedes the functionality of an earlier tool called the Light Lister. To open the Light Explorer, you can do it in a couple of ways. One is from the standard Scene Explorer. You can launch the Scene Explorer from the main toolbar button. And then once in the Scene Explorer, you can go down to the pull-down list at the bottom and choose Light Explorer. And now we see all these light properties. I'll close that to show you. I can also open that from the menus. Go to Tools, All Global Explorers, Light Explorer. The most important properties of the lights are the color and intensity. I'm going to move these columns over closer to the left so I can make this window smaller. I'll just click on light color and drag that over, and also light intensity, drag that over too. I'll make some changes to just adjust my lighting scheme here, make it a little bit less blue and a little bit more contrasty. But first, let me rename all these lights so I know what I'm working with. I'll select one here, and it'll be selected in the view. Omni 001 is a fill light. Let me rename it. I'll click that and call it Fill 01. This next one, Omni 002, is also a fill light. Click it and rename it Fill 02. Omni 003 is a bounce light. It's down here below the floor. It's there to simulate light that's bouncing off the floor. I'll click that in the Light Explorer and call it Bounce. Omni 004 and 5 are rim lights. Now with everything renamed, it'll be a lot easier for me to tell what I'm working with. Now I want to reduce the saturation of the blue on all of these ambient lights or fill and rim lights. I can click on the light color swatch and just reduce the saturation on that to a value of 10 and click OK. And I'll do that for all four of these. And when I'm finished, I'll have less extreme color in the view here. Once I've done all that, I can also play around with the intensity. It seems to me like I've got too much ambient light and I want it to be a little bit more contrasty with darker shadows. I'll leave the spotlight at its default value of 1, but I'll play around with the values of some of these others. For example, that bounce light, I'll bring that down a bit. Click in the light intensity field and that'll highlight it. And to change the value, you'll want to drag your mouse across it as well and then type in the value, 0.1, and press enter. That just brought the intensity of the bounce light down just a little bit. The fill lights also are a bit too bright, I think. I'll click there and then click and drag and type in 0.25 and press enter. And likewise with fill O2, click on it and then drag over it and type in and press enter. And now I've just sort of fine-tuned my shot a little bit so that my lighting is a bit more pleasing. We can take a quick look at that in a final production render. Just click in the perspective view and click render production to take a look. In CG lighting, we have certain advantages over a real-life studio. For example, we can make it so that lights only shine on certain objects. That can be very handy. For example, we have these rim lights here. The purpose of the rim light is generally to accentuate the edges of the figure to make it stand out from the background. But we don't want the rim light to actually shine on the set. That's going to create too much illumination. It's going to reduce the contrast and make things look flatter. So in a real-life studio, that's a challenge. We need to use some special equipment to make sure that we focus the light only in certain areas. In CG, it's really easy. All we have to do is just exclude the light from certain objects. This will be a dramatic example. I'm going to increase the intensity of these rim lights here. So I'm going to select that back rim light, set its multiplier value up to, let's say, 0.8. And you can see here we're getting a strong rim on that figure. And we're also getting a lot of splash here. It's starting to overexpose. Likewise over here, this other rim light, I'll set its multiplier up to 0.8. And we're getting a nice sort of halo on the figure, but everything else is getting washed out. All we have to do is click on the exclude button here. But before we do, let's go ahead and render this so we have something to compare it with. So here it is with the rim lights increased in intensity, but not excluded. I'll go ahead and clone that off so I can compare it. Then minimize. Select the light and go to the exclude button. And we want to exclude everything except the character. That's going to be the box primitive, all these Hydra primitives. And hold down Control and select those. And the ground plane as well. Then click this arrow pointing to the right, and those will get sent over to this column. And anything in this column is going to be excluded. That light's not going to shine on those objects. And you can see here that it's defaulted to exclude from both illumination and shadow casting. This light has shadows disabled currently, but if it were casting shadows, then with these current settings, these objects would not cast shadows. Alright, click OK, and we won't see any change in the viewport, unfortunately. But we'll go ahead and change up the other light, select that other rim light, click exclude, and once again send the box, those 4 Hydra, and the plane over into the other column, and click OK. Alright, so here's our last rendering, and I've got a copy of that as well. Set this up side by side, and click render with the exclusion. So on the left, we have the rim light only shining on the figure and not anything else. You can see this is not blasting out here. We're not getting any hot spots on these set pieces here. And then this is without the exclusion. The rim light on the figure looks great, but everything else is overexposed and blasted out. Now that's a bit too intense in terms of the rim light. I wouldn't actually use that high of a value. This was really just for illustration purposes so we could see a really clear example. In fact, I would probably bring this multiplier down a bit, maybe 0.5 for each of those. We'd still have a nice rim effect, but not quite so strong. Alright, render that. There we go. So we're getting a pretty nice rim on the figure there, and maybe getting close on that so we can see it more clearly. Cool, so we're getting the rim light on the character and nothing else. It does look like this is a little bit overexposed here too, so I'd probably want to play with that some more. But that's the principle behind exclusion. And that's really a good introduction to standard lighting in 3ds Max. And that concludes our chapter.